Welcome back, class. Okay, so I promised you a faster way to do this. So before we start number 2, let's look back at problem number 1 that we just solved a few moments ago. And here's what I want you to notice. Do you notice that right here we said that we were going to use -6 and -2 from doing our multiplying and adding thing. And then if you look at the final answer, you notice how that -6 just turned into the number 6? You notice how that +2 turned into the number -2? You might be wondering to yourself, I wonder if that's a coincidence, or I wonder if that will always work. And the answer is, as long as there's no number, this is important, as long as there's no number in front of the x squared term, you don't have to do all of this. If there's no number in front of there, you can literally just take this number, change the sign, that's where it will hit the ground, change the sign of this, so it'll hit the ground at -2. So let's take a look at what this would look like to do it a little quicker when we do problem number 2. So I'm going to make an x, and I'm looking for two numbers that multiply to the number on the end. So I want two numbers that multiply to 100. And I want two numbers that add to that middle term. So in this case, what is that, -20? So I'm looking for two numbers that multiply to 100, add to -20. Again, I just focus on the multiplying at the start, and I worry about the adding later. So ways to get to 100. 100 times 1, that would make 100. 50 times 2. What else? 25 times 4, that would make 100. 20 times 5, right? 20 times 5 is 100. And 10 times 10, obviously 10 times 10 is 100. And what I'm looking for now are pairings here, where if I add them, I could get them to get to -20. And I'm thinking 10 and 10. They could get to 20. So I'm going to focus on this one right here. But I don't want them to add to 20. I want them to add to -20. So to do that, they'd actually both have to be negative, wouldn't they? So -10 and -10. If I add them together, that's -20. If I multiply them, do I get 100? -10 times -10 is positive 100. Yeah, that works. So last problem, when we got to this point, we did all of this stuff. But we noticed that you didn't really have to, did you? Because the -6 just turned into 6, and 2 just turned into -2. And so we're going to just say, we got our answers. This quadratic will hit the ground at, change the sign of this, it'll hit the ground at 10. And it will hit the ground at, well, 10. And that's the answer. Since it happened twice, that's actually called a double root. So let me just explain real quick what that means. So it hits the ground at 10, and that means that this one didn't hit the ground 2 times. It just hit the ground once at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so it looks something like this. It hits the ground at 10, but it just like barely touched the ground, and then it bounced right off it at that spot. So this one only has one solution, and it's 10. A little bit faster this time. At this time, I want you to try to do some problems. Well, let's get rid of this. I want you to try to do some problems in your homework assignment on your own. Specifically, take a moment in your homework to circle problems 3, 4, 6, 8, and 9. I'd like you to do those 5 problems on your own now, using what we just learned from doing 1 and 2. Before you stop this video, though, I just want to point out that sometimes you'll see something happening in these 5 problems where it'll look a little bit weird. I'll just make up something right now. Like, what if you saw something like x squared minus 20x equals 15? what would you do with that? Well, before you made your x, you would want to get it equal to 0. So you would, in this case, what, circle 15, right? Excuse me, not circle. You would subtract 15. And that would turn this into x squared minus 20x minus 15 equals 0. And then you would do your x. You're looking for numbers that times to negative 15, looking for numbers that add to negative 20, and then you would just keep on going, right? So the point I'm trying to make here is that on some of these problems in the homework, I'll make that up a little bit. In some of these problems in the homework, the problem isn't going to start with it being equal to 0. So if it's not equal to 0, just do what you have to do to move things so that it is equal to 0. Then you can solve the problem just like we did in problems 1 and 2. So go ahead and give those problems a try in your homework, and then I'll have another video ready for you. Thanks.